With PSSE, Siemens PTI offers a comprehensive high-end analysis software solution for all your transmission system planning needs. The PSSE base package can also be further enhanced to include a rich ecosystem of optional add-on modules. This video demonstrates how PSSE and PSCAD co-simulation is performed. Co-simulation or hybrid simulation allows PSSE and PSCAD simulations to be run together as one big simulation, while exchanging the boundary conditions between simulations at every larger time step. This is done using several user-written models in both PSSE and PSCAD. Typically, the starting point for a co-simulation is the big PSSE case. The area to study in detail is first modeled in PSCAD, with a multi-port network equivalent representing the rest of the system connected at the boundary locations. The system that is already modeled in PSCAD is then removed from the original PSSE case, and a revised PSSE case is prepared by connecting a multi-port equivalent at the boundary buses. The calculation of a multi-port network equivalent is based on LDU reduction technique, which involves complex mathematical calculations. The E-TRAN tool can be effectively used to perform these tasks and to automate the co-simulation process. The simple Save NW case is used to demonstrate this. The raw file and DYR file are the required starting point and are available in the PSSE example folder. This slider diagram shows the topology of the system. For the purpose of this example, the shaded area is going to be modeled in PSCAD. There are 10 kept buses in the PSCAD circuit, including 3 boundary buses. The rest will be modeled in the PSSE portion of the simulation. First, let's create the PSCAD case using the E-TRAN tool. To save the case translation settings, open E-TRAN and create a setting file. Under Options, Preference, choose this file to add it to the project settings of the PSCAD 4.6 case. In the next tab, the location of the PSSE version 34 raw and DYR files are specified. A name for the PSCAD output file is specified, and version 4.5 Plus is chosen. During the translation, the substitution library feature, which lets you add complex devices such as DC links and SVCs to the PSCAD case, is not considered. Only E-TRAN free launch translation is used. Form equivalence for co-simulation is chosen. The location of the SAV case is specified. The batch file required to launch the PSSE portion of the simulation is pre-prepared and specified here. This BAT file contains setting up the PSSE case, compiles CLoad 4 activities, and running the PSSE case with faults being applied. A starting port number is given, say 3000, and will be used in both PSCAD circuit and PSSE DYR records. In the next tab, the list of kept buses in the PSCAD circuit is specified. Here you can choose one of the buses as the starting bus, and you can leave the E-TRAN advanced options at default values. In the next tab, the PSCAD simulation time step and finish time are set, say 50 microseconds and 10 seconds respectively. Click the Convert button, and E-TRAN will create the PSCAD circuit. Next, open the PSCAD case just created. The case is drawn starting from bus 3004. The network equivalent page contains a 3x3 multi-port network equivalent created by E-TRAN. The socket mapping component is populated with port numbers starting at 3000. The interface start time is specified as 1 second for this example, which is sufficient for the PSCAD case to reach the steady state. The CH-out SPI component, which uses a separate port, is used to import PSSE channel quantities to PSCAD for interactive viewing. The user can add any PSSE quantity from this drop-down list. The auto launch component is also populated by E-TRAN, so the PSSE case can be auto-launched from the PSCAD case. That completes the PSCAD case preparation. Note, this whole process could have been done manually by copying and pasting the individual components from the E-TRAN library. This process of setting the parameters correctly, however, would be time-consuming and error-prone. With the use of the PSS E-PSCAD co-simulation module, this process is fully automated. You may have noticed that E-TRAN has created a Python file in the local folder during the translation. This is the script you need to execute on your PSSE case to obtain the revised PSSE case required for the co-simulation. Let's run this script on the PSSE case. Here is the revised case with 3x3 multiport added. It also creates a temporary DYR file that contains the records for the PSSE co-simulation models and must be appended to the original DYR file. Finally, quit PSSE and go back to the PSCAD case. You will notice the PSSE case is auto-launched, and the communication starts at 1 second. In this example, a bolted fault is applied on the PSSE side at bus 3004 and cleared after 0.1 seconds. The finish time of both simulations must be equal for proper termination of both PSSE and PSCAD cases. Faults can be applied from the PSCAD side as well. The library files with the binaries for the PSSE models are provided for all the PSSE versions. DLL files are provided for PSSE version 33 and up in order to avoid compile and cload 4 activities. Keep in mind you may still need to perform compile cload 4 if you have any other user-written models in your PSSE simulation. Also, remember to use correct DYR records with the DLL files, as they're different from standard CONNET DYR format. The co-simulation can be extended to any number of PSSE and PSCAD cases of different versions, depending on the complexity of the full system. The auto-launch component residing in the master case can be used to auto-launch all the other PSSE and PSCAD cases. That is the power of PSCAD co-simulation.